Balancing Equations, Part 5, Decomposition Reactions. In a decomposition reaction, the compound breaks apart, often forming a gas. Sometimes it forms a gas and an oxide. Sometimes it forms elements. When balancing decomposition reactions, generally balance atoms in this order: metals, nonmetals, polyatomic ions, hydrogen next to last, and oxygen last. We're right here. In a decomposition reaction, you have one compound and then an arrow. There is no plus sign on the left side of the equation. If you just have two elements, you'll make two elements in the compound. If it has a carbonate, it forms an oxide and carbon dioxide. Hydroxide, oxide, and water, and so forth. So you see a lot of times you're making gases or water. These are your common gases. These charts will be available on the quiz. Example 1. Use the balancing equations flowchart to determine the type of chemical reaction and to balance the following equation. We can tell this is a decomposition reaction because we do not have a plus sign on the left, and we have two or more products on the right. We have two aluminum. Notice the carbonate breaks up, so we have to do each individual element. 3 times 1 is 3 carbon. 3 times 3 is 9 oxygen. On the right, we have 2 aluminum, 1 carbon, and 3 plus 2 is 5 oxygen. The aluminum is balanced. Let's do carbon next. We will leave oxygen for last. We place a 3 in front of the carbon dioxide, and now we have 3 carbons. Aluminum is balanced, carbon is balanced. We have 3 times 2 is 6, plus 3 is 9. The oxygen is now balanced. The final balanced equation is aluminum carbonate decomposes to form aluminum oxide plus 3 carbon dioxide. Example 2. Use the balancing equations flowchart to determine the type of chemical reaction and balance the following equation. We know this is a decomposition reaction because we do not have a plus sign on the left. Notice chlorine has a subscript 2 on the right. When chlorine is by itself, it is a diatomic molecule. It has to have a subscript 2. We have 1 sodium and 1 chlorine on the left, 1 sodium and 2 chlorines on the right. Let's start by balancing the chlorine. We place a 2 in front of the sodium chloride, and now we have 2 sodiums and 2 chlorines on the right, but we have to fix our sodium on the left. We multiply sodium by 2. The final answer is you have 2 sodiums on both sides of the equation and 2 chlorines on both sides of the equation. The balanced equation is 2NaCl yields 2Na plus Cl2.